My channel. Today we're gonna work on the question reverse linked list. It's an easy level question and we're gonna try to solve this question using recursion. Given the head of a singly linked list, reverse the list and return the reverse list. So looking at the example, 1, 2, 3, 4, 5 linked list turns into 5, 4, 3, 2, 1, so it goes backwards. In example 2, 1 pointing to 2 turns into 2 pointing to 1. And if it's an empty list, we just return nothing. So let's start writing the code. I'm gonna solve this using Python, and we're gonna use recursion because we're on the recursion chapter right now. So first thing, for recursion, we're gonna write the base case. Base case is a case that terminates the loop in the recursion. So our base case is gonna be if head is none or head.next is none, then we return the head. We return itself. So this catches if head is none. Basically, it catches this case. If nothing is entered here, then we just return nothing, which is the head. Or head.next is none, which is more for our recursion. We return the head itself. I'll explain this later. And then let's have a previous node. Previous node goes self.reverse list. This is gonna be the recursive call. Head.next, and then head.next.next equals head, and then head.next equals none, and we return the previous one. Okay, let me explain this. So basically for each call in the first instance, head is 1 is gonna be 1 pointing to 2, pointing to 3, pointing to 4, pointing to 5, right? Head is 1, and then basically 1 with all the links, and then p equals self.reverse list head.next. So then p equals, now the next call, it's gonna be at 2, right? 2 pointing to the rest, and then it goes, it doesn't hit this base case. We check if this is the base case. It doesn't hit because 2.next still has like following stuff following it. So then it enters this again to p equals 2.next. Head was at 2. Now it's at 3, right? 3 still has linkage following it. So 3 doesn't terminate this recursion. It goes on to 4. And we check 4, is 4 equals to none or 4.next equals to none? No, so it goes into 5. And then finally at 5, when we go to the space case, 5.next equals to none, right? Because 5 is not pointing to anything. Then we return the head, and the head is 5, so 5 is not returned, and p is assigned to 5. And then because 5 is returned, it goes back to the previous call. So the function goes and returns node 5 back to the previous call. And who was calling 5? It's it's 4, right? 4 was calling 5, and so it returns to 4, and the head was actually at 4 in the previous call. So we do 4.next.next equals head. What does this mean? So 4.next equals 5.next equals none, so it becomes basically 4 points to 5 before it points to none, right? The previous call 4 was pointing to 5 and pointing to none, and now we want to assign 4 pointing to 5 and point to 4. So it might be a little bit tricky to understand this in the beginning, but basically what we're doing is we're doing 4 pointing to 5 back to 4, and then we want to break this linkage here. So then the head is still at 4, 4 now points to nothing. So we deleted this part of the link. So 4 is now the one pointing to none. Before 5 was the one pointing to none. Now 4 is the one pointing to none. And we return p, which is 5 pointing to 4. And then it goes back to the previous caller of 4, which is 3. Now, 4 is pointing to none, and then we want to point 3.3.next.next. So Let's write the next call. So 5 still points to 4. Let me just do this. So currently 3 points to 4 in the previous call of 4, right? And then 4, was changed to none. So 3 dot next should now be 3 pointing to 4 pointing to 3. And what is already pointing to 4? 5 was pointing to 4, right? So now it turns into 5 point to 4 point to 3. And now we want to assign 3 points to none. And we return to the previous color, which is 2. 2 points to 3 points to none, right? So then it would be like 2 point to 3 point to none. And then we want to assign it to next equals 2. So 2 points to 3 points to 2. And then 3 is already linked here, so 5 point to 4 point to 3. So it will all be linked like 5 point to 4 point to 3 point to 2. And now 2 is pointed to none. And then we go back to the previous call, the first call, which is at 1. So basically, here, 1 points to 2, and 2 is currently pointed to none, pointing to none, and we want to assign 1 point, not equals 1, right? So 1 points to 2, pointing to 1, and we want to assign 1 to none, so this linkage is destroyed, so it's 2 pointing to 1. And what is pointing to 2 before? It's 5, 4, 3 pointing to 2, right? So it would be 5, 4, 3 pointing to 2 pointing to 1. So then at this return, there's no more recursive calls left in our call stack, so we finally return the last one, which is 5, 4, 3, 2, 1, which is the answer. Let's run this. Yeah, so this is how I would solve recursive linked list using reverse linked list using a recursive function. And the time complexity for this would be O of n, because we have to go through every node in the linked list. And then the space complexity is also O of n, because the space used by the call stack, the recursion could go n levels deep. So let me know if you have any questions, and thank you so much for watching.